We have traveled halfway across the world to do something that I've wanted to do since I kind of got into 3D printing. And so before the Sanjay Mortimer Rap Fest, we decided, hey, we're 85% of the way to Prague. So why don't we go visit Prusa Research? So come join us as we give you an unprecedented look on the inside of how some of the printers that you guys love or love to hate are made. It is 0 degrees centigrade, it is overcast, and it's actually raining a little bit. Florida man is very cold. So let's go inside and let's see some amazing things here at Prusa Research. Let's get into it. The first stop on our tour is Prusa Lab, which, if you don't know, was previously like an open makerspace, but since the human malware came through, it's been turned into a rapid prototyping facility, very much like what we do at 3D Musketeers, but here in the Czech Republic. And there's some amazing things going on here. To tell you about it, we actually have Andre. Tell us about what's going on. What do you guys do here?
Thank you, welcome. Well, we used to start really working as a proper fab lab a couple of years ago and having 100 members per month, 50% were changing constantly. So it was like really growing community, and we enjoying like helping them to start mainly. So it was rather, I felt ourselves like a event space and culture center. There was lots of things to do. And after pandemic came, we decided, because we are in the company, it's not that often for fab labs, they are usually like public space and stuff like this. So we were forced to think about the model, and instead of like helping people in the beginning, we decided let's find a project and help them through the prototyping process until they are able to create a product, or doing the installations for festivals, just using 3D print, showcasing them as a crucial process in the development, not only the product in the end by the 3D print, but also in the process.
It's often that people don't really understand that 3D printing is more part of a process than it is an end to the whole thing. People see 3D printing and they say, I would never buy something like this. Well, that's great, because you probably wouldn't in an end use case where you're actually building a product that goes to market. 3D printing is called rapid prototyping for a reason.
True. And I think that this is the great way how we can help and kind of also boost the use cases, helping our main content department, which is doing really great job by promoting mainly the printers. We are trying to promoting the 3D print in the collaboration of special partners, or in this project what we discuss. So this is our 3D printing corner. Also a little bit.
It's a little bit of heaven, isn't it? I know for you guys it's just another day at the office, but I really enjoy this.
Yeah, we really enjoying here to having all the machines here. It's also a little kind of simulation of our 3D printing farm, you've probably seen. Also, it works as a showcase for our clients. Sometimes we invite them here and let them see how the prints works. Sometimes we also do the test prints for our customers if they just need to prototype or test and make sure if this is the good way for them. But to be honest, this is just the first corner we visit, because as you know, the prototyping needs, the power of the prototyping is in the combination of different prototyping techniques, right?
As much as we all love 3D printing, it is just a step. Like, don't get me wrong. If we could use 3D printing for everything, a lot of us probably would, and a lot of us do. I mean, on the camera setup that is recording us right now, there's quite a few 3D printed parts, and they're being used as end products because nothing else exists in the world, and I don't have access to CNC machines all that readily, nor, if I did, do I want to spend their time making, parts that can be utilized for 3D printing. And that's the value of the technology. It lets you prototype fast, lets you prototype affordably, and do it in such a way that it also looks really freaking cool. Like, imagine if this was your shop, and if you were doing this as a business, you brought clients in here. That's a look. And all the orange, right? Half the freaking printers are running pure orange filament. I'm sure there's no reason for that. You guys' favorite color is green, right?
You touched the really important or maybe funny thing that I have my masters here, and they are usually working with different materials, but sometimes I found them that they are maybe too lazy to go buy some aluminum profile or something, they will already print it, so you can see it all around.
Yeah, a lot of the is this shelf fully? Oh no, it's why is it? What is printed on this and why? Or is the whole thing printed?
No, there are the construction in it, but this was sometimes we need to cover it, so this is meant to have like
lets
proper,
you.
yeah.
Okay.
But as you said, like the many features in this building are printed because it's just easier than find some on a shop and go there if you can do it in a few seconds, right? So
there's resin over here. It's nice you guys have the resin separate because, as we all know, resin is toxic. But it's nice to see the machines separated. You guys have individual ventilation on the machines as well. And I notice a nice little piece so that you can lock the lids open. That's a very, very nice touch. But this is a really awesome piece. But there is more to Prusa Lab than this really awesome print.
Yeah. Let's have a look.
Yeah. Come on. As we talked about earlier, 3D printing is just part of the process. Let's say that you have a blast gate. This is used for a vacuum collection system where if you have dust, chips, whatever it might be, that you need to vacuum up, but you want to have more than one, you can block it off. But this is made of metal. And if you watch the end, you'll see how we found that out. But you can't always get exactly what you want. Sometimes you have to make it. And here we have a piece that is probably printed on an XL.
Exactly.
And it is a big inlet with quad outlet. And you guys are actually utilizing and prototyping this for another lab here inside of Prusa Research.
That's exactly what we absolutely love about 3D print, that you can actually adjust whatever you need to your recent needs, and this is just an example that even I feel that the knowledge of 3D modeling and 3D printing give you kind of this kind of freedom, and also helps you a lot. And this principle is actually used in all our projects. Sometimes we just having recently a meeting with the guys from National Theatre. They were challenging by the problem of some particular things in their installations, and they don't using 3D print that much, and they just realized that this could be way how can they actually do the things easier, faster, and of course the process of prototyping, it's for them something would give them the opportunity to make it even more efficient in the end. So
that's like one of those great things about 3D printing, but also one of its biggest downsides. You can make anything. And often when people don't understand the tech very well, they think it can go to the nines, when realistically, we need to keep grounded on it and make sure that everything is kind of done correctly. And you could do this on a 5-axis mill out of a big piece of aluminum or steel if you really wanted to make it expensive. But why? Printing is this is actually quite dense. Printing is perfect for this scenario. And being able to show companies that have never thought of this technology before how not only is it useful, but it's a step in a process is really good. We find that sometimes we start people inside of a regular workshop and then move them into 3D printing. So they start to see, like you guys have here, a lot of 3D printed parts. But this is, where someone, if they were printing something next door, they could come here if they needed to drill out a hole, add a heat set insert or something like that. This would all be done in here. So your hand tools, your whole wall of really, really well organized metric hardware. Thank you for that. And I will say this is one of the cleanest hand tool workshops I've ever been in. So props to whoever set up the protocol for keeping it clean, because these shops can get out of hand fast. I love it because there's so much printed stuff in here, and it shows the commitment to utilizing printing all over.
I think this is part of our everyday life. In this specific workshop, you need to, as you said, like sometimes you have big pieces and you need to carry it to the smaller, or you need to just this finishing and the post-processing of the 3D prints. This needs to be separate from the other parts of our workshop. So that's why we're doing this. Working with the fillers, with the sprays and stuff, and kind of compiling all the things to the final state of the thing, and then to be able also to document it. So this is kind of room we're using for this kind of multi-purpose. activities. Yeah.
And you guys are also utilizing rooms like this, and the one maybe we'll be able to shoot in, to do internal prototyping as well for future machines, projects that come out of Prusa Lab and into a larger company, right?
It's important to say that we're working as a kind of prototyping workshop for our colleagues developers. We are not ourselves developing the printers as it is, but we are here to serve developers to be able to do the iteration fast.
Yeah.
Either in the 3D print, but mainly with the CNC milling and CNC lathe. So
a developer comes down and says, I need this part. You guys said, we got you, and you make it for them.
Yeah, and great is that once normally you would ask some other company, they have to have a time for it, you have to have a budget to address someone else, and then you have to, approach them for other iteration because it's usually needed in development, right? So instead we have it here, and on like daily basis, maybe in half an hour you can come again and ask, hey guys, could you do this another way, because I realized that was not working like this and that. So
this is like every hardware company's dream, is to have a prototyping facility kind of in their basement that they can leave alone. They operate on their own, but when they need it, they just walk downstairs and say, pretty please, can you make this for me? And then you guys remember you're all kind of part of the same large company as the umbrella. And like, I guess so. And because you guys also, this is not just for internal, you do a lot of companies that come to you and say, can you do this?
Yeah, exactly. We are actually dividing our capacities to this mainly two areas. One is to work on the internal projects, either development of some crazy stuff like large-scale 3D print by robotic arms, and so we're developing our own extruder, being able to kind of eat the pellets made of grind filaments, which is not going through our quality control, because there is lots of waste out of it. So we are the one who developing the solutions how we can use this waste, either print, as I said, or make desks, and then from the desk material you CNC some crazy stuff. I will show you some skateboard what we made out of this material.
Nice.
So this is the one thing, but on the other hand we are also here to collaborate, for example, with the Festival of Lights. Every year we made like the big installation with travel around the world, representing the company in 3D print, but also the artistic intention which is there as an input.
That's where 3D printing really kind of bridges that gap between engineering and art. Mechanical engineers are not notoriously known for being very artistic, and people that are incredibly artistic are not really known to be mechanical engineers, and 3D printing brings those two together where you can get a lot of crosstalk between those two. And that's what I love about it. Maybe that's because I'm not very artistic and I'm not really an engineer, so maybe that's why I found 3D printing. I don't know. But there's more to Prusa Lab than just 3D printing and hand tools. You guys have lasers and CNC machines as well, right? Are we able to go look at the CNC? All right. Come on, let's go. Now over at the electronics area, because, well, if you're gonna make something cool, you gotta make it have some sort of electronics in it, right?
True.
There's a whole facility here, including soldering Arduinos and the ability to embed electronics into 3D prints. But it all has to be supported. You guys have some cool projects. Can you talk about one of the ones that you got going on?
Yeah, I would like to show you one module of a project we called Fluidum. It's actually the second version of the arts installation being made for Festival of Light in Prague. Right now, traveling around the world for other festivals. The thing is that this is one module from 90 in one kind of big art piece. They are covered by mirrors. They are programmed in Grasshopper, the Rhino, where you can map all the movements of it. And you could see if there are like 3 different legs working.
Oh, that's a custom board you all built too.
Yes, and this is actually, we firstly made the boards for our some of our project, even internally in the SMT line, which is here in Prusa Research. And we also, and this is again the showcase of other 3D print, which makes actually this happen.
Yeah.
So I advise you to see it either on some festivals nearby or on some videos, because it's pretty exciting.
Yeah. I've seen videos, I've never seen it in person, so it's really cool to be able to see. Can I?
Yeah.
It's really cool to be able to see this whole component with magnets, and it's ball and socket magnets, but on top of it, servos and custom PCBs at the same time. That's really the power of rapid prototyping, isn't it? And taking 3D printing and making it a part of a project and not the whole freaking project. That's awesome. Yeah. How long did you guys spend in prototyping this?
Well, there was a half years of prototyping first version, when there was just one, you can imagine, like 2 legs. So the mirror originally was in a 1 level, but moving around.
Okay.
And this is the second version, completely new kinetics, which is 3 kind of legs, and it gives us the ZX like additional. So it was like altogether maybe a year and a half of prototyping.
Wow.
But not like daily basis. But for this it was great that we were able to use knowledge of our engineers from Prusa Research. So we asked them for kind of peer-to-peer reviews, and they also helped us how to solve like some kinetics problems.
That is really awesome, right? To be able to work with engineers from different departments to put it together to build what is objectively a really cool piece. Are these all individual, or do they communicate to each other?
Well, the first version, we call it reflection. There was 9 pieces collected into the one. So basically, it was not working as a modules. But then the second iteration, or the second version, there was the idea also that the medium on top could be replaced. There don't have to be necessarily the mirror, but you could put some other thing on top, maybe some glass monument or whatever. So in the end, it should be work as a separate modules, and you can program them separately.
You gonna release these in open source?
Maybe one day.
Because I know what I want to do with this, and it's really dumb, but I want to put a lot of individually addressable RGBW LEDs in this, and utilize it not only as a cool piece in a background, but because you can set the angle, and with a white component, you could set your color temperature. You could have perfect wraparound lighting if you wanted to do photography or something like that. And utilizing just a couple of sensors, you could map it perfectly.
Wow.
I'm a geek for this weird stuff, but
yeah, the original idea actually come from the architects who want to have like daylight all the day. So basically the facade opposite of your house could be covered by this and just like mirror the lights of sun. So it was the original idea.
I'm thinking of something similar, but instead of using the sun, I'm using an artificial sun.
That's what I'm talking about.
Oh, that's so cool.
But actually, it could represent our activities, what we are doing here in this hardware accelerator. Maybe I didn't talk before about this. We, instead of having lots of members, we rather choose some of them to work on the idea in the end of the whole process of prototyping, ideally finishing with a scalable product. And this is also really powerful when you make it in this kind of company, because we can coach them in the way of packaging, in the way like, you know, like this kind of shipping, because we ship all our printers from here to all over the world. So we have lots of experience in this.
You have experts in every field here.
Basically, this is cool because we can actually, again, polymers. So we can discuss like the different features of the plastic materials they want to use in their products, and so on and so on. So we're trying to squeeze the potential of the company and you know, kind of aim it and boost the startups what we are accelerate thanks to this.
That is awesome. I have a prototyping company as well. It's what I had before we started the YouTube channel. We still do a lot of prototyping. I wish I had packaging engineers and experts in shipping and experts in all of this. I have to be the guy that figures it out most of the time. And I agree with you. Allowing this project to be open to anybody to work on would cause it to take so much longer. You want the right people that are dedicated, that are motivated to see it happen. It's, you know, the adage of too many cooks in the kitchen it ends up making the dish taste bad. And this is certainly an example of doing it right, even down to having the branding on the back of the circuit board. This is super cool. Thank you for showing this.
Thank you.
And there you guys have it. Prusa Lab is, well, way more than what we can specifically show you, because that's kind of the fun of having a prototyping business. There's all the cool stuff is what you can't talk about, and some of it you unfortunately can't show on camera. But if you guys do want to get in touch with Prusa Lab and get your ideas made, and you happen to be in the Czech Republic, we have links to that in the description. But what's a good email for them to reach you guys at?
You can definitely reach us on email, info@prusalab.cz. But also you can find our work on Instagram or LinkedIn or Facebook as well.
And of course, all of that is down in the description as well. Guys, thank you so much for watching this tour of Prusa Lab. Andre, thank you very much.
It's great to having you here.
This is awesome. It is an absolute maker's paradise. And if you all ever have the opportunity to come out here, I highly recommend getting a tour of the factory. It is something that you can do by reaching out to Prusa via the live chat. It is absolutely worth it. Highly recommend it. But this is not the end of our stop here, but it is the end of this video. Don't forget to leave a like and get subscribed. But stay safe out there. Don't forget to call your loved ones. Let me know what the coolest thing that you saw here was. And as always, keep making awesome. Have a good one. This was something that I didn't know was ever going to happen. I never thought that I'd be able to see an AFS in person before I'm writing the check for one, most likely. This is one of the first big products from Prusa Pro that are positioned toward businesses and industrial applications. Talk to us about what's going on with the AFS.
So what we can see here is first like a stage of the AFS, because the concept of the AFS is a modular one. So basically we have one basic module here, which comes with the robotic hand. Then it's a module with the 9 printers, which can be multiplied. So basically you can put in theory up to 6 of these modules next to each other. And then we have module with the we call it shelves, where the finished and empty sheets are stored inside and ready. They are ready for operator to pick it up or to put an empty sheet back to the process.
So these printers are designed if you wanted to print something a lot of times, maybe a lot of individual different things, like when at the Dubai Expo you guys made a bunch of snowflakes to bring snow to the desert, but it's also used if you want to print a big thing, but do it in a lot of pieces. But why would I as a business want the AFS when I could just get, in this case, 9 machines to do the same work? What does the AFS do that I couldn't do myself?
A big inspiration for us was our own print farm, where we have a lot of experience how to do the farming on the 3D printer. And one of the biggest problem and issues was the human factor. So basically when you have a lot of human interactions in the system, there is always a possibility to induce some errors and some failures and some stuff which you don't want to handle in a big scale, right?
And so humans are kind of expensive, right?
That's
good humans are often expensive.
Exactly. That's the one reason. Another aspect is regular maintenance. You need to keep a track of the printers running basically 24/7, of how many print hours they are printed, and then arrange maintenance accordingly to the needs. Because when the printer is broken, it's not producing, and this costs you even more money.
And it's not always about the money lost in prints, it's the time lost, because then you have to basically turn the dials up a little faster to catch up. Human factors are one of the biggest issues for failure amongst any business period, whether their CEO might be a little crazy or the staff weren't properly trained. Human factors are what can cause inefficiencies, and machinery don't need no union mandated breaks. That's the nice thing about it, and the AFS solves these problems.
Another point, and also this comes why we choose, for example, this size of the print bed. Some or many people are asking us, like, why you didn't make it like XL size?
Right.
XL size means that the print time is approximately 1 day or even more for such a huge prints.
Yep.
And this means that if from the 2-day print, the downtime is like 6 hours, the percentage of the yield of the printer is like reasonable. But if you have a lot of small prints, like 2, 3, 4 hours, and the downtime is 6 hours till the operator comes and change the print sheet, then the yield is already like drastical. It's more than 50%,
right.
And this is something which costs you money at the end of the job.
Now, I'm sure a lot of people watching have been through an instance where they've got this big print job, so they try to build the plates to be maybe 18 hours, maybe 24 hours, maybe 25 or 26 hours, so they can minimize downtime. We do this all the time. We try to run 18 to 20 hour print jobs so that you have enough time for the printer to cool down, enough time to do any maintenance, and then you can get the next job running without really pushing your time every single day.
Exactly. But now imagine that one of the pointy, tippy part in your print sheet just fell off, then the whole plate is ruined. With this concept, you can just plan more efficiently because the parts don't need to be fit that much on the print plate, so you can print more effectively. Because on the FDM, the print time is linear or almost linear with the parts on the print bed.
Yep. If one part takes 1 hour, 2 parts is probably going to take 2 hours.
Exactly.
The only time where that doesn't always scale is when the part is really tiny and you have a relatively high minimum layer time, so you have to sit there and wait for everything to cool down.
Exactly. So, and this is because we have the robotic hand, which can operate even with the really hot build plate. So we can just take out the printed plate immediately, place it into the shelf, come up with the empty, clean sheet, put it back to the printer and start the new print immediately. The downtime right now is approximately 2 minutes. 2 minutes takes the whole change.
That's pretty good. And with the AFS, the printer actually goes down to the bottom, and that's where the build plate can pop up off the magnetic sheet. Then the arm can grab it, right?
Exactly. Exactly.
And then you store your clean, ready-to-go plates here for the most part? No?
It basically the algorithm chooses the shortest way.
So, so you have some over here and some over there.
Exactly.
Oh, okay.
The only difference is how we track the sheets in our software on the back end. So then the operator can see, okay, this one is already printed. This one is ready to be printed.
Kind of the cool thing with these plates, and you're not going to find this on your average Prusa Mark IV or even on the XL, all of your plates have QR codes and other codes because the arm is scanning everything to make sure it's where it needs to be and it looks okay, correct?
Exactly. According to the industry needs, we want to track everything from the beginning till the end. So basically, when the job starts, the print sheet is scanned with its unique QR code, with its unique ID, and then we keep tracking this unique ID through the whole process. And at the end of the process, we have a full, like a birth certificate of this part, where we know when the print started, who print started, on which printer was printed.
Full traceability.
Exactly.
Wow.
Full traceability. What material was put into the printer, and so on and so on. So this is kind of like a next generation features which are required by the industry standards these days.
I would love this so much. I wouldn't lose parts and have to reprint things. I don't know where the friggin' parts went because the machine would track everything. And you might say, Grant, how do you know this is an industrial grade? It's because it has a nacelle, okay? Industrial machines have these. These are status LEDs. They're often called a nacelle, and it's there so that at a glance you can look over a shop floor and see what is happy, what is angry, and depending on, you know, how much granularity you have, why the machine might be angry.
Exactly.
And this is really designed for industry.
You will have your own Prusa Connect server running on your own premise,
Which you need. Yep.
Basically on many companies this was like a showstopper, where uploading to someone else's cloud or some cloud solution, it's
Can't do
no-go.
it.
It's one of the biggest features.
We do a lot of work that necessitates maintaining air-gapped and offline machines. And if they go online, we get into lots of trouble, and not just the legal type of trouble. And businesses like mine would see a benefit from a machine like this because everything is internal. It's at our facility, we control it, and then at that point it is up to my network security to make sure that everything is clean.
Exactly, and you are responsible for that. So
that's okay.
This is exactly, we listen to our customers where they really requested such a feature.
Yeah.
Then there is I would say like hot swappable mechanism to change the printers, where you just take it out, put it back, the system recognizes that the printer was changed, the production starts immediately, so the maintenance can be done on some service desk next.
No downtime.
No, or minimum downtime.
Right.
Downtime. Voila. Then you have all the good features of the Prusa Connect with additional features of farm tweaked, I would say, Prusa Connect, where one of the feature is our own neural network trained to detect some print failures, and
that's convenient.
yes,
Because if I don't have to wait for a print fail to finish for the machine to go in and change it out, I am reducing my downtime. Because technically a machine that is running but has failed, as far as I'm concerned, is down. So Tommy, tell me about the value of this automated system. Because as a business, I get it, little downtime and everything, but there's more to it than just, hey, we're constantly monitoring your prints, hey, we make sure that everything is good, hey, when the prints are done, we get them out of the way. There's more to it than this, right?
Yes, basically the Prusa Connect can be accessed through some API. So for example, if you have some ERP system where you are tracking all your orders and everything, this can be like backwards filled or taken the data from the ERP system. So it can be like a self feed, or I don't know, self-fed unit.
Right, it
which
auto
just
updates.
It automates everything. So if we can say it really like in a nice way, it just falls some parts out of it with no hassle.
And so the arm is moving around here. We've seen the arm moving a bit, and that's taking pictures, right?
Exactly. While the old printers are printing, the manipulator, the unit with the camera, is patrolling each of the printer and taking pictures of the prints, where we can later on analyze it on the fly
To find if everything is okay or not.
Exactly. So even like we can do some basic spaghetti detective and some of basic recognition of print failures.
And speaking of spaghetti, you guys have named these machines, and these are all after foods. I'm assuming calamari is calamari, that's
Exactly.
octopus, right?
Yes.
Paella, tortilla, croqueta.
Yeah.
Yeah.
They have everything
I love
in
it.
common. They have everything in common, and these are Spanish foods.
Yep.
Or typical Spanish foods. The names can be chosen by the.
Yeah, you can put whatever you want.
Because it's easier to say like during some maintenance or during some operation, it's really easy to say like, hey, calamar has some issue, or the calamar nozzle is clogged probably. Can you please check it? And you know exactly where to go.
Yep.
Because you know which printer it is. But if you say like printer number 22, it's probably then you need to find the position of this printer and so on. So this is for us, for developers, it's much more easier to recognize the printers by their name than by some numbers or some random rubbish.
As someone that had, when I built all my Mark IIIs, they each have a different accent color. So they're named after their color. There's yellow, there's blue, there's white, there's green. And that's how I know, because there's only one machine for each particular color. But having the names like this works, and of course they have a nice little place for the nameplate. So nice little touch there. But Tommy, what is your favorite part of the AFS?
It's the journey. I really enjoyed the journey, where we still, as a concept, we presented this at the Dubai Expo 2020, and like in some really crazy movie, the day after we put the PR announcement of the AFS, the phone started ringing like crazy, and from the really big companies and really big players, like, hey, this is what we really need. Like, take our money, we need it now.
It's 100% true, right? I look at this and say, I need it. I can't afford it. If it has a nacelle, I can't afford it. But yes, companies that want to do rapid prototyping in-house, they might have a Mark III, a Mark IV, maybe they've gotten an XL for whatever reason, and that's great, but then you need an engineer to watch it. You're paying them 80 grand a year to watch the printer and make parts and all that, when you could spend some amount more of money and get a machine that does it all itself. This is a staff member that, if it does complain, you put a new one in its place and you're done, and there's no staff training needed. This is what business looks like for additive manufacturing. See, there's that distinction between 3D printing and additive manufacturing. While they are technically the same thing, additive to me is the professional and industrial side, where 3D printing is like a Mini or a Mark IV, although the Mark IV is like prosumer at this point. This machine brings 3D printing and additive manufacturing into the business world, and it looks like a business piece.
Another use case which we didn't mention are educational
schools.
Schools and universities. Because the whole system is accessible only through Prusa Connect, and local entity of this server. You can easily control who has rights to print, who has possibility to print what. And for example, you can have a bunch of students which they have some reserve time on the machine. So for example, you have these 3 printers for 2 days and like do whatever you want on there,
and that's it. And
you have the full control over this, right? So this is another like business side for the AFS is educational sphere, where right now the universities, they have like labs with the full of whatever Creality, Enders and Prusas and I don't know whatever they have there. But the students fight between each other.
They do.
For example, they just cancel someone else's print and they just put their own print, and they say like, the print was failed, so I cancel it. But so this is something what solves also these kind of issues, where you have like full control who is printing what and at what cost. Right. So
I love that end of semester. Every semester, the college kids call me, can you help? I need a print tomorrow. I need to pick it up tonight. The school didn't get it done. My print failed, yada, yada, yada. And a lot of it is because they're college kids and they don't time manage. And I know that I might feel like I'm preaching to some of you, but time management is very important as you get into the professional world. And a system like this, even if you don't time manage all that well, with enough machines, it wouldn't matter. Exactly. And it can do it all manually. And you can queue things up, right?
Exactly.
I guess the only thing you would have to do manually is change out filament color if that was needed.
Yes, filament changing is not yet automated, but we are working on that. But the concept is based on that we use only 2 kg spools, which is quite a lot of
it's quite a lot of filament. Yeah.
And another good thing is that you can have a different filament in each printer loaded.
Right.
So the Prusa Connect detects for which filament this was sliced. So it recommends, or it gives you only to the printer which have loaded that.
That's nice.
So loaded that kind of material. So it
Reduces errors from people that don't know what they're doing. Because no offense to a lot of colleges, but sometimes they just dump the printers onto either a staff member or students that aren't exactly trained. So if you are in that position and you want help, reach out to us. You can comment down below or you can email me directly, youtube@3dmusketeers.com. We offer 100% free training to anybody in the education space. Specifically, I would prefer to focus on educators, but if there are students that need to learn as well, I will help you learn to use the printers so you don't call me freaking out that you need stuff done and you can't get it done. Because doing this right, it's not easy. And it's why machines like this exist. Because it is difficult to run a print farm on your own.
Yes.
It would be cool to start seeing AFS make parts in the farm upstairs. That would be cool to see.
Yes, this is actually what is right now ongoing.
Oh, okay, hey.
By the end of this year, or like in a few months, let's say.
Soon TM.
Yeah.
Friday. It's always Friday.
Yes.
Yeah.
So next Friday.
Yes, next Friday.
We will start building additional 3 units, and these 3 units will be distributed in our company, within our company.
Nice.
And one of them will be in the testing department, of course.
We were up there earlier.
They will beat out of this machine everything.
Yeah, the testing guys are not kind to machines, but that's how you know they work well. We're going to be going to the farm next, where you can see tons of printers. I'm told almost 600 printers up there running, and I feel like a bank of 9 AFS printers could probably account for 15 to 20 regular printers that are running up there just because of the throughput capabilities.
Exactly. Yeah. This is approximately our calculations also. One of these 3 pieces will be put also to the farm, or actually next to the farm, because right now we don't have like space where to
I've
fit
seen
it in.
photos in there. There's no space.
No space.
No space.
Yeah, this is actually happening soon. So maybe next time when you come, there will be already maybe 3 or 4 of AFSs there.
So Tommy, if people want to learn more about the AFS, get information on it beyond what we've shown here, and maybe just get contact for pricing, where could they go for this?
The best way is to go to our website.
Okay.
This is afs.prusa3d.com.
Okay.
Or contact directly on our info@prusa3d.com email and ask for the AFS, and our B2B partners will contact you soon.
And that's the deal, guys. This is pretty much designed for B2B, although I'm sure there's a few of you makers out there that are like, I need it, and might actually have the budget to put one of these in your house. Whether or not you have the money for a divorce attorney is the next question, but hey, that's for future you. Current you just needs to figure out how to get this inside the house without the significant other knowing. You feel me? I love to see build plates on each side, the ability for parts to be put away, and it looks like we have some parts finishing up here, so we're gonna get to see the arm do its thing, where it takes one print off on the print bed, puts it onto a shelf, grabs another print bed, puts it in place, and starts printing again. The things that you do, except you touch the bed with your greasy fingers and you gotta clean the freaking thing. This is robotic, it doesn't have that problem. Anyway, guys, I could go on and on and on about this machine. It is super, super awesome, and it is empowering businesses to create more, faster, and more better, for that matter. Tommy, thank you so much.
Thank you very much.
It was awesome to see this, but we gotta go. We'll see you later. This is considered oversized baggage, right? I can just take one of these home with me?
Yeah, we can wrap it for you.
Here we have one of the coolest sorting systems that I have ever seen. It takes up to 7 different types of hardware. It goes up these belts here and into hoppers up there at the top. Everything is printed. We have these containers are printed. Everything here is printed. And even the little buckets on the belts are 3D printed. They use Pinda probes right there and MK3S control boards, the Rambos, for the sorting process. The system is able to count here. And if it is over, it goes back down into the hopper there. If the count is correct, it falls down into a sorting system. From there, you have bag on roller. It comes down to here, where this tube, which is an inkjet printer, actually prints on what it is with a QR code. And then a sorting arm goes through and sorts everything to the appropriate container. This is rapid prototyping for manufacturing at its finest. We can see Mark III heaters used for the system to actually heat seal the bags. And it looks like they have filament to make sure the bags stay open. And potentially Nextruder dry gears for the moving of the filament. This is absolutely brilliant. And if we look up through those mirrors, you can actually see the parts rotating inside. Also, hi. And that enables everything to not get stuck, move appropriately throughout the system. This is likely a final prototype, but it's actually built so well that it is in full-on production. We can see thousands of pieces of hardware over here as well, all done on this machine. There's your inkjet printer, the vat of ink. I just absolutely love this. It's so mechanical, and it's done with parts that are in-house. It's just super, super cool. Here we can see the bins. If the count isn't right, they get dropped back down so that someone can take it off using the dovetails and pop it back into the bins to once again go through the whole system. Let's check out the first prototype. Here is prototype number 1, designed for one set of bolts or screws. It goes up a belt that is actually printed in TPU. From there it goes into a similar sorting system that will make sure everything aligns right, utilizing a Rambo board once again into a funnel. And look, we even have a Mark III screen. And then, simply, down once again. This is prototyping at its finest. Being able to take an idea, try it, and then be able to turn it into something that runs in a production atmosphere. They took the mistakes and learning lessons made with this for the big one. What do you guys think in those comments? Because this is real prototyping right here. And then you see it in a manufacturing environment. This is a company that is dedicated to doing everything via open source. From a business perspective, it's not cheap because you need your own in-house prototypers, but when you can control every aspect along the way, it's a really cool system. Psst, psst, psst. Hello. We have interest. We have 3 massive carrots, so it's fine. Uh-oh. Uh-oh. We got one. All right. Oh.
Hold on. I got a double fist of carrots.
So gentle.
A little squeaky sounds.
Is there any more?
Yeah, a couple.
Look at how fluffy they are.
It's yours.
Hello. Man. So yummy. Such carrot. Hello.
Something like that. I'm sorry.
Shane, you want to feed him? You sure? Oh, okay. Okay. That's fair.
No, that one up here.
No, I got one left. I'm gonna get you the black one.
I'll just grab this one. Over here.
Excuse me. Excuse me. Excuse me. No. No. No.
The one right
No.
up here.
No. No.
Yeah.
Okay. Well,
Yep.
I'm sorry. I have no carrots. I have none. I'm sorry. We are here at the SMT assembling line for Prusa Research, and I'm like a kid in a candy store over here. Everything from custom screen printing for all of the solder masks that are required for the PCB, to inspection for that screen printing, from one machine that does 30,000 parts per hour, to a second machine that does 30,000 parts per hour, to two more machines that could do 30,000 parts an hour, but they do really big components, upwards of 0.8 by 1 centimeter. For you Americans out there, that is about a 1/4 inch by a 1/2 inch. That's a big component when you're talking about pick and place machines. And these machines use a rotary system to make that happen. But Prusa did this mainly because it kind of sucks when you have to outsource to other companies. You have to trust they know what they're doing, that they have good quality inspection. And when you can bring it all in-house, it obviously makes things way easier for not only control, traceability, But also, if you want to develop something fast, you don't have to send it out and get it ordered from somebody. You can literally build it right here. So in these machines right now is the XL X Buddy board, which is the main control board for the Prusa XL. And it's going through the stages down the line. But it is a double-sided PCB. So they actually have to flip it over. They store hundreds of thousands, if not millions of components here, and they're all on reels, like the ones here that you see. The machine will grab them up. Now you might say, Grant, that doesn't look like there's anything on the reels. That's the point, because the parts are so freaking tiny. You're talking all the way down to 0.1 by 0.05 millimeter, 0.1005. Crazy tiny components. This facility is a maker's paradise because electronics are just part of the process in making a Prusa 3D printer. Doing your own boards in-house is something that very few companies out there do, and it ensures quality, consistency, and you can also hide really funny things in the PCBs as well. So from screen printing to placing and all the way down at the end, reflow. It's not a wave soldering process, it's reflow, it's hot air, which is also really cool. Then there's inspection, there's PCB routing, and they have a really cool X-ray machine. But this is just a small portion of the process that it takes to build a Prusa 3D printer. So let's go see what else is required to make things that are made here work everywhere else. Come on. Part of the process of building a Prusa 3D printer is testing. We are here in one of the testing labs at Prusa Research where, yeah, it looks like they do have a fair bit of fun, but the fun is actually work. These printers go through rigorous testing, and in fact, back through those doors, we have machines that have been printing since 2008 that are still printing to this day. And here, we have the guy that runs the whole show.
Hi, my name is Jindřich, and yes, I'm the head of the testing department in here.
So you guys primarily deal with making sure that the machines that end up going out have been almost abused in there. You guys are running these machines all the time to make sure that even in a farm environment, like what we do at 3D Musketeers, these machines are going to last, and if there are problems, you can identify them early before we find them.
Yes, well, that's why we are here, and the machines are quite a beat up from the use. Our mission in here is no issues should leave the building, or they should be at least known about. And then there's the decision if it's a critical issue or if it's some shifted pixels, which would be unfortunate if they were to block the release of the firmware per se.
Right, right.
Especially if it's got some really useful new features, which people are waiting for or can help them a lot.
So you guys actually handle a lot of the testing before things go out to the general public then?
Yes.
So you're the ones finding all the bugs before we find them?
Hopefully, and be glad you don't find the most major bugs we do find in here.
All right, I gotta ask, what's the craziest bug that you found?
Well, let's say years ago when we were about to release a Mini, we found out that would you look at that? If you are in the wizard, if you just start the wizard of the Mini and you leave the machine, or the motors heat up to like 180 degrees.
That's a little spicy for a stepper motor. That would kill the stepper motor, wouldn't it?
Yeah, it was. I believe it was at least borderline.
That would melt the plastic.
It did.
See, that's the value of having a testing facility where people that love your job, obviously. You guys have all these awesome pieces around here, but you're able to test it before and identify things that, how many of you never turn off your printers? I never turn, they only draw like 2 watts and getting to the power switch is a pain in the butt. I'll leave them on, who cares? The value of making sure that it's not gonna go to 180C on its own is really important. But at the same time, you guys are also doing a little bit of work to make sure that everything is fully polished before it goes out the door.
Exactly, and it's both the products being developed and the products being maintained, which means when the product is being developed, we are getting the iterations, we are reporting both to the firmware guys and the hardware guys. This isn't working, these bearings will stop working with this clip after a couple of days, and if this feature doesn't work because it does this and that.
You ever had bearings go out before? The noises they make? The grinding and screeching? We had that a few times. Not on Prusas, but we had them on a few times. Actually, one of them was on the E3D Titan Aero, where they had to replace the ball bearing with a dryland bushing because the ball bearings would seize and rust. Because the oil wasn't good enough, especially for a humid environment. We're from Florida.
I see.
Very humid. What is your favorite thing about what you do here?
I suppose the variability of the work. You will pretty much never know what you will do next, because the priorities can shift quite a lot.
Yeah.
I can come to one of my guys 3 times a day and tell him this is your priority for this morning, and actually around lunch, sorry, this needs to be done first, and well, actually this has got the top priority now. Yes, you could say the work is still the same. We are still testing the machines, the same firmware, the same features, but on the other hand, the issues are still new and plenty.
Right.
Before we get them back to the developers.
Right.
So I'd say the variability of the work.
That's always good. Those of you that have day jobs and aren't just making for a living might know that sometimes day jobs can be a little monotonous. It's the same thing every single day. And, well, you guys get to chase bugs the entire time and then figure out how they occur, why they occur, make it repeatable, and then be able to fix it so when it does go out. The stuff that you guys are doing here, does that include some of like the alpha things that we can get from GitHub, or is this pre-alpha?
Well, we tend to get the rawest versions of the features and firmwares. So the firmware testing itself could be split into again two parts: the feature tests and the big tests, as we call them. Okay. The feature test is, we have a new feature, we have, let's say, auto dim of the screen on the printer.
Right.
So we have to get really deep into it, and will the settings work? Does it do what it has to do? Are there some edge cases when it doesn't work? Can it happen so that the screen dims forever, let's say? And if it does, we have to try at least to find a way how to do it. So let's say if you remove the USB drive while the screen is dimming, then it will just lock itself forever. So I'm making all this up. It's just the type of the work we are trying to do when we are doing the feature tests.
Those little edge cases that might happen once or twice, but will set the entire Twitter community off.
Exactly.
Because, oh, this one thing happened.
Yeah.
When it probably shouldn't. We all tend to get angry at things very easily, when realistically it's because you found an edge case that nobody else has found. But that's kind of what you guys do. You guys try to find those edge cases.
Exactly.
That's awesome.
And well, two things help us with that. And so first of all, sitting at the desk and just torturing the machine. And then also our testing print farm, when we are running prints pretty much non-stop. As I would paraphrase a certain book, filament must flow. Because that's, as we are printing pretty much anything, as the people are printing pretty much anything, you can easily find these cases, and rather than if we were just stuck printing benches.
Right. Benchies are somewhat useful, but they get very boring after a while. Making a giant Tyrannosaurus skull, now that's a lot of fun.
And it's actually also a test. It was when the pecs were introduced into slicer cutting.
Right.
So it's not all that visible, but it's held together by pecs and the dovetails. You can see the dovetail in here. It was one of the first dovetail cuts in here.
All right, this does sound like a lot of fun. You guys do have a lot of fun here. Well, we're gonna sneak back there and take a look at what's going on.
Sure.
Thank you very much for letting us kind of poke around and see some of the really awesome stuff. This is all Galaxy Black?
It is. Actually, Galaxy Black is the most common filament I have in here.
How many kilos was this?
I didn't weight it, but I'd say it could be like 20, 30. I was also testing the lighting in there, which didn't fare well for this type of thing you need to assemble, because it tends to wobble, but it's got its different uses, the lighting in filament.
Ultimately, people are going to make stuff like this. So.
They might as well. So somebody better test it first before they get it.
It's what we talked about before. The thing that you get with Prusa is you get machines that actually run pretty well. These guys here make sure that any potential problems that might exist can be found fast, and hopefully fixed before it ships. But ultimately, There's no way to be perfect. Mistakes happen and things get out there. But the trick with Prusa that many other companies don't do is you guys actually get solutions out fast. You have a problem, you find it, you get a solution, and it goes out to the public, and that is amazing.
We are hard on the printers and even harder on the developers.
Oh man, I've seen how hard you are on the printers. Do we get to see the developers, or are they hidden off somewhere?
Yeah, they are in the barn.
Okay, that makes sense. Well, awesome. We're gonna go take a look in the back. Thank you so much for showing us around.
Go ahead.
This has been awesome, seriously.
Nice meeting you.
Yeah, absolutely. Guys, stay tuned. We have so much more here at Prusa coming at you right after this. We are here in the testing facility that has a lot of printers. Like I'm actually taking some notes as how they store their filament and everything like that because, well, these guys are doing it for real here. From models all over the place, from creators that you might know to test printers that we might have to blur. This facility is where the rubber meets the road in making sure that the machines that end up in your all's hands work as well as you might expect. This is where they abuse the machines, they find bugs, they patch them, and then they test to make sure that those patches actually work. And that way you don't have to do it and you hopefully leave support alone every now and then. But hey, if you need the help, Prusa Support is available. I think last year it was 24 hours a day, 7 days a week for 360 days, which is pretty darn good, but every now and then the Alpacas do need some time off from typing the support responses. We have everything in here from test prints for input shaping. This is actually the test print they use for input shaping. This one is specifically for the Mark IV for the different values so that they can see what works and what doesn't. You might say, well, Grant, we have accelerometers. You're right, you do, but accelerometers are not always perfect. And if your mount for that accelerometer is not really tight, you're not gonna get a good reading. Being able to utilize tests like that is phenomenal and a great way to ensure that what ships actually works. That's the big thing here. The last thing you guys want to do is get a printer and then have it be not functional for a certain amount of time until you actually get the right parts, get the right firmware, whatever it might be. Or, you know, have a machine that you can't update firmware on. Anyways, this lab is truly amazing. And this is not the print farm. We still have to go to the print farm. I think you guys are really going to enjoy it, but I'm told, kind of feels like Florida up there, and considering it is -2 degrees Celsius outside right now, that might actually be kind of nice. But I am amazed at what is going on here, the beautiful pieces that have been made, and behind the camera is a pile of parts by artists like Fotis Mint that are just utilized for testing. And then, hey, staff get to take them home and show them off at home or put them on their desks. That's always cool. They do go through a lot of filament here. But those of you that have been dealing with stringing on the XL, that new firmware that dropped gets rid of it. Guess who did all that? These guys did, which is super, super cool. And I hope you guys find this as cool as I do. Maybe I'm just a turbo geek, who knows? But seriously, there's so much more to see here. So let's go on to the next area. Come on. It would not be a trip to Prusa Research without visiting the print farm. Almost 600 machines running around the clock to prove that 3D printing can actually be a viable source of end-use manufacturing. Love it or hate it, Prusa Research uses a ton of 3D printed parts in their own machines, and to prove how good their machines are, they use their own machines in production, everything from Mark IVs over here to Mark III S Plus, who knows? But these machines all have very subtle changes from the regular machines that you guys might have at home. And a lot of that's because there's 600 of them in this room. It is like Florida in here, and it is snowing outside right now. Each machine drawing 100 watts or more is gonna produce a lot of heat. And so around you might see some ducts up top, and there are ducts all around the machines as well to help remove some of that hot air so that the room doesn't become a venerable swamp. But there's also some things that we've noticed on the machines, like little test coupons that are used when the machines go into service, because they service the machines here on this farm once every 1,000 hours. So don't feel bad if you haven't maintained your machines ever, because you might not have had 1,000 hours on it. But if you have had 1,000 hours, it might be time. It's really cool to be here. It's like a kid in a candy store, if you will, a dream to be standing amongst the machines that built a lot of the printers that I have, that you might have, or maybe you're looking at getting. And honestly, it's pretty darn cool. This is the thing that everybody wants to see, and it's the image, I'm in the print farm. But to me, it's all the little subtle things that make this space different. Like the machines here, they have ASAPC PCF on them. The screen cover is a completely different color, so that you know that these machines are designed for hardened materials. The actual printed parts themselves are able to withstand higher temperatures, and they're fully enclosed so that the heat stays where it needs to stay. That kind of thing is really valuable in a print farm atmosphere because, well, there were a lot of people behind me, they've all gone away. But there are a lot of people working here, and you don't need to have people coming up asking me, hey, what's on this machine? Hey, what's on this machine? Hey, what's on this machine? Makes it really easy for you to figure out what is printing, what material, and where at a glance, which is super cool. On the Mark III, some of the little things they've added blower fans to the extruder motor because it gets so hot in here that it can actually cause heat creep problems. And we've got little test coupons. They're on the front of every machine, and that tells you when it was last serviced, and you can actually see a test sample. But something that is kind of interesting to me, and those of you that like to change your nozzle often might enjoy this, on every one of the SD cards, or even on the Mark IVs, on the flash drives themselves, is a color code, as well as on the SD cards, a number that tells you the size of the nozzle. Those of you that have multiple printers, you might have one that runs a 0.6, maybe one that runs a 0.8, and maybe a couple of them that run 0.4s. But you have to remember what is what. And I've definitely never put a 0.4 print into a 0.6 nozzle. I've never done that. And I'm sure none of you have either. But this makes sure that that never happens. That kind of stuff is so cool to me. This space is proof, real proof, that you can actually use 3D printing in a production atmosphere. Not only is Prusa building a printer that is gonna last, but at the same time, they believe so much in their own equipment that they use their own equipment to make their own equipment. But that begs the question, and let me know what you guys think in the comments about this one. What came first? The Prusa parts or the Prusa printer? I would love to know what you guys would print if you had access to a farm this big. You could make thousands of parts per hour without a single problem whatsoever. It is insane how fast you can produce parts with almost 600 machines. And this, of course, was the room where famously Prusa attempted a world record for the most amount of 3D printers simultaneously 3D printing at once. And I believe they actually got that record. They did actually end up selling a lot of the machines for that world record. It was a whole thing where if you ordered a Mark III's at a certain time, you got one with a number on it, and it was one of the ones included in that world record attempt. Does it have any value? No. Is it freaking cool? You bet your keister it is. That might be the only thing that's cool in this room, because my God, it is hot in here. But I'm leaving my clothes on for the most part. Patreon. And even further, they're using their own filament that is produced right below us. And while unfortunately we can't film in there because there's a lot of secret sauce that goes on for those machines, it's really cool to see it in action up here in a massive, massive scale. I could stand here all day and just watch the machines go. It is therapeutic, if you will. And those of you that have watched your printers move, you know what I'm saying. If you had access to a farm like this, let me know in the comments what you would print on something like this. Thank you to everyone that has made trips like these possible. Without you guys, we wouldn't be able to film in the freaking print farm. All right, guys, that's it for the farm, but we are nowhere near done with Prusa, so come along. We have more rooms to check out. Let's go. Come on. And from the farm, we come in to inventory. This is where the parts that are printed on the farm get stored. You have to make sure that you're printing more than you need immediately. So when you do a Black Friday sale and sell so many printers, the people on the farm don't come and try to harm you. This is where all the pieces are stored for inventory, so that when you order a machine, it shouldn't take that long to get it out to you. Everything from, parts for the XL and the Mini and Mark IV, SL1S, CW1S, Mini back there, MMU3 is over here, and it's all well marked. And oh yeah, everything is printed. Gotta love it. I just think it's so cool. There's all this inventory too. I wonder how many kilos are stored in here at one time. Love to know your thought on that. Not too much to see here, just lots of bins full of plastic. So let's go see something really interesting. Come along. Inside the assembly, we have everything from testing electronics, making sure that the printers are working perfectly, and that the boards that you get, and even the cables that you get, are all working as expected. Further down, we've got really, really intricate electronics testing, but it's all done with printed components. It's everything from electronics testing to assembly for the screens going on back there. Here we have bearing installation, and then the load cells. And on the second table back there, we have the planetary gear drive and the extruder for the next extruder assembly. Super cool. Through here we have boxes that are getting built and packed. Everything that needs to be done by hand is all done by hand. But there's also a robot back there. There's a universal robot that is handling the stacking of boxes onto the pallets, which is super cool. Packing of the neck extruders, all the way to basic frame assembly. So if you buy a fully assembled printer, here are the people responsible for making sure it comes done right. Because of course, you can do a fully assembled or a kit. Electronics assembly, extruder assembly back there. It's a really, really nice setup. And for all you Makita fans, Bosch has entered the chat. Everybody here is just working hard to get printers out the door as fast as possible, even down to assembling the printers piece by piece. And unlike the kits that you guys would build, these, well, have all the pieces immediately in front of you and ready. This must be nice for that level of organization. And from there, the machines go to final testing, where the sample print is applied to the bed before the printers are boxed up and shipped out to you guys all over the world. This is super cool. I mean, there's got to be 50 printers here. Printers all over that are either ready to go or in some form of testing. And from here, they go onto these carts, which go to another floor where they are put into boxes, a label is applied, and then the alpacas run them to your front door. Hi, Joe. How you doing? Just a floor below, we have the assembly area for the Prusa XL. Everything from neck extruders to motherboards and daughter boards to the back panel and power supply distribution system. Over 60 printers per day are going out in just this facility alone, and I have it on good authority that they're ramping up production. We have the infamous tool head mounts, lead screws, and linear rails. Over there are pulleys in the back, and all the jigs as the printers go down the line are all 3D printed to maximize space. Again, it's just cool. We have rail systems, inventory, adding screws into extrusions for the Z-axis. This is something that is near and dear to my heart because I just finished my XL build. We have extruder assemblies, the systems for tool changing, and we have control. A way to make sure that, well, everything is right. QR codes and traceability. There's the shot everybody loves. The actual planetary drives with the sun in the middle and the planets on the outside, using a custom 3D printed grease gun to make sure that the right amount of lubricant is applied where you need it. A really, really cool system here. Everything is built to maximize productivity, down to quite literally the carts themselves, making sure that the machines can fit as well as possible. But once they're fully assembled, they have to go into shipping, which is back this way. They're gonna be moving to a larger facility here very soon to, well, increase productivity. That's what it's all about. Here's testing for the amazing multi-segment heat bed. Make sure that, well, works as it should. And here's where packing and shipping of the XL occurs. Again, custom-made jigs, custom-made tables to ensure that everything is as efficient as possible with your semi-assembled. And of course, it wouldn't be without the Haribo. XL for an XL. I love to see the use of jigs and fixtures that are all custom made to fit the use case. It reduces waste, increases productivity, and keeps the branding the same colors. But there's more to go. So let's go to see the rest of the shipping empire that is Prusa Research, because there's a lot of printers that leave this facility every single day. And well, about 6 of them are XLs. So if you ordered one, it's coming soon. I promise. After your printers get assembled, they have to get shipped out. And that's kind of the scary part, because at that point, everything kind of changes, because it goes out of the hands of Prusa and into the shipping companies that have a tendency to drop kick boxes. So you guys have even developed a super high-tech method for testing, which is a 1 meter high measurement to drop boxes.
We are dropping the boxes.
But Thomas, talk to me about what you guys do here to ensure that printers get to where they need to go.
Okay, we pack it well. That's the point. Anything else?
Hey, short and sweet, but you guys have a lot of knowledge and time and expertise and a lot of failures along the way to get to where it is now. To get the packaging to where it's not only pretty much 100% recyclable, it's up near 80, right?
It's, I would say, with some packages, it's 100% because everything is just the cardboard, the package itself.
There have been a lot of processes along the way to ensure that packages get to where they need to go. And back in the day, it was black plastic you wrap the boxes in, then it was white plastic, and now they're pure cardboard because you guys have gone through those rigorous tests. But Thomas, can you tell us what it's been like to get to this point?
Okay, it took a lot of job. We had to work hard for this. As you told, back in the days, we wrapped the packages, but now we are using only a cardboard to ensure it's fully recyclable. If you get a paper box, you have to throw it into the bin, and that's it, to recycle it. So
it's awesome. That's pretty cool.
I like this. I like this.
Gotta have the forklift.
Yeah.
That man is a ladies' man, because anyone that's forklift certified, they know what's up.
That's the one way how to put the material up.
Yeah, hey.
We got the lift, we got the displays, and we got obviously hands to keep it on, to just handle it with stairs. That's it.
Makes life easier. That man knows what he's doing with the forklift too. That's high quality work right there. But you guys have 2 floors here of packaging that ensures that everything from a regular nozzle all the way up to a fully assembled printer
that's it.
Is done right.
Yes, that's it. If you take a look upstairs, we are shipping all the master products, which means all the printer, all the upgrade goes from this place. And here downstairs, we are shipping all the, we call it small orders.
Okay.
It means that each filament, each nozzle, each steel sheet, everything goes from here. We have shipped till in November 2023, we shipped already 40,000 packages.
40,000 packages out of this one facility. Yes. So let's go take a look and see what it takes to get the orders from inside the facility to your doors. Here on the 2nd floor, we have the packing and shipping department with This station made specifically for Mark IV assembled. Then back there we have Mini and Mk3 kits. Yes, the Mark III is still being produced, but very few of them because, well, the Mark IV is the new hotness these days, and they're doing upwards of 200 Mark IVs a day. Talk about a lot of 3D printers going out of the door, and each one of them is hand-packed and sent down the line to the delivery alpacas that will get them out to you. There are 4 lines here serving the individual types of printers and other things that might come out of Prusa research. It's amazing to see a well-oiled machine, if you will, because shipping is kind of where the rubber meets the road for these boxes, because at that point, the printer is out of the hands of Prusa and is in the hands of whomever is gonna be drop kicking it for whatever shipping facility it might be. And getting the packaging right matters a ton so that your printers arrive safe and sound. But there's way more to shipping, so let's go back downstairs and see what else is going on. Coming down the stairs, we land in the parts department, where pretty much every single part that you would ever want to order is stored. From nozzles, SD cards, Prusa Lube. What you do with it is up to you. If you were to order 1 or 2 nuts, for instance, these are all individually hand-picked and everything is marked, and of course, 3D printed boxes for it all. Everything has a place. And then when it's all ready, the boxes come out and they end up here to get wrapped up and ready for shipping. That way, if it's cold or raining or snowing even, your packages arrive in perfect shape. This is what it takes to really run an efficient operation, from loading docks to storage, and even for storage of things that don't sell all the time. But making sure that you maintain inventory numbers so that when an order comes in, it's not days, weeks, or months. Should it be something that is small and readily available? And with traceability and the QR codes, it makes everything easy to get together and put in boxes. And of course, pretty much all the packaging is recyclable. And that concludes our time here at Prusa Research. But there is so much more unreleased footage that didn't make it into any of these channel videos. So if you want to see things like walking around Prague in the snow with POV footage, make sure to join our Patreon, YouTube channel members, PayPal, and printables or thangs. All linked in the description down below. I hope you guys enjoyed watching this as much as we enjoyed filming it. It's been an amazing experience to fly all the way from Florida to Prague to just learn more about 3D printing. And I'll tell you, from somebody in the business world, seeing all of the vertical integration that has occurred here to make building these machines possible in a way that guarantees consistency is pretty cool. Everything from making their own circuit boards to printing their own parts for their 3D printers. Prusa has invested a lot of money into people, almost 1,000 employees strong as of recording this video. And I'll tell you, that's a big company, no matter where in the world you might be. But do let me know in those comments what your favorite thing is. And if we make it out again, what you want to see, if we can show you. But I want to give a huge thank you to Prusa Research and all the staff here for being incredibly nice, opening their doors and showing us everything that it takes to go from idea to 3D printer. And of course, thank you to Mr. Joe Prusa himself for allowing this kind of thing, because we've shown you guys things that have never before been seen on video, which is super cool. Well, if you haven't yet, leave a like and get subscribed. Do stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome here at Prusa. Take care. As we talked about earlier, 3D printing is just part of prototyping. Let's say that you have, the friggin' thing open. All right, let me do that again. Looper, just a flow.